Welcome back to our final session on circular bioeconomy. This session is moderated by Dr. John Kettle, Director, Commercial Operations and International Relations at Natural Resources Institute of Finland, Luke. Dr. Kettle, over to you.
Yesterday, it became clear that we will have 2 speakers instead of 4 speakers in this session. So we will still try and hold the time. And the 2 speakers who will be speaking, I'm sure will enjoy having a few more minutes extra. But so they don't get too enthusiastic, I decided I should introduce our institute so that you would understand a little bit more about us. And I promise not to take the edge off the whole event by giving you shall we say, a straightforward presentation. We'll get back to the technical presentations very soon. So yeah, we are Luke, Natural Resources Institute Finland. And if I work out how to do this, Luke is quite new. So we were formed in 2015, but we have very deep and long traditions. So we were a merger of 4 or 3 institutes: MTT Agri-Food, Finnish Forest Research Institute, and Finnish Games and Fisheries Research Institute. And you can see in orange the years when these institutes were started. In fact, one of them is older than Finland, one is the same age as Finland, and one is from the 1970s. So one of them is actually younger than me. I'll let you work out how much younger. And we also have the Information Centre of the Ministry of Agriculture and Forestry, so we're involved in the statistical work and statutory work for Finland. Even though we're a merger of these institutes, I won't go into great details about organograms and that type of thing, but to say we have 4 large programs, and the 4 large programs are represented in these orange circles. But yes, within these 4 circles, you can see the programs we're running: adaptive and resilient bioeconomy, climate smart, carbon cycle, circular bioeconomy, and profitable and responsible primary production. 4 programs that are interdisciplinary and are challenge driven. And I think whether you are here in Finland or elsewhere in the world, you realize these are challenges we are facing locally and globally. We have 22 locations around Finland, co-located with 12 of the university campuses. And I won't go into great detail on all of the programs, but I wanted to focus just briefly on this one, the Circular Bioeconomy Research Program, because this program, I think, has most relevance to the speakers in this session. And what we are trying to do within this session is to bring about really bringing the knowledge from the boreal forests and the Nordic forestry forward, so whether it is in wood construction or however you'd like to see it. And the speaker from India from IIT will focus on the use of algae and water treatment. It's another circular economy type topic. And then we have topic related to the biogas plant investments that are ongoing. What we're trying to do is really bring forward resource efficient production systems. And of course, not least within this work is the nature-inspired functional materials. And maybe you'll hear a little bit about that as well. So at that point, I would like to stop my presentation. If there were any questions, I'm sure my colleagues from Luke here will also answer them if you wish to ask them. And I think now it would be a good time to move over to Professor Sanjeev Kumar. So if I stop sharing from this screen. So on your screen now you can see Professor Sanjeev Kumar Prajapati from Hydro and Renewable Energy Department at IIT in Roorkee. He is a leading expert in algae-mediated wastewater and resource recovery in India. His PhD work has been focused on coupling algal biogas production with wastewater treatment. He has many notable awards, including excellence in academic research, distinction in doctoral research, amongst many others, and is also a guest editor of 3 prestigious special issues and reviewer for various SCI journals.
Good evening to all. I am Sanjeev from IIT Roorkee, as introduced by Professor John Kettle. So today I will be talking about the resource recovery from the wastewater using the algae-mediated processes. So, so before moving to the resource recovery, we should consider the some view on the wastewater. So the wastewater, if we consider the major contributor in terms of the wastewater generation, so we have the industries, we have the residential areas from where the sewage is being generated, as well as the agriculture sector, which is the one of the major consumers of the water, particularly in India. So these all scenario, like we include industry, residential areas, and the agriculture. So they use water from the freshwater resources, and the water that has been used is being discarded and termed as wastewater, which is a major challenge in the developing countries like India. Like if the water is being generated, if it is not being properly treated before it is being discarded to the environment, it will create lots of environmental issues, particularly eutrophication in the water bodies. So there is a need, or in fact, there has been some development in the processes or the technologies that can work to treat the water for its recycling, along with the recovery of the valuable resources. It may include the valuable products from the wastewater itself, the nutrients that are being into the wastewater streams, and the energy recovery. So in the today's talk, I will be talking about some part of my research that we are carrying out at IIT Roorkee with my team and the colleagues here. So where we are trying to link the algal-based technologies with the three different kind of wastewater. So first among these category is the RO reject. So everyone knows that RO plant are usually used for the production of drinking water. So there are few reports that highlight the use of RO concentrate from the industrial wastewater treatment plant, but we have been focusing on in this work, particularly the RO reject that is being generated from the drinking water plant. Then second, the hydroponic system, which is very much developing in particularly in India and other countries. So this is a kind of soilless cultivation in which we use the concentrated liquid media for cultivating the different crops, including vegetables. And the third scenario is the sewage treatment plant that receive the sewage generated from the residential areas and the institutions, and that treat it, and finally they focus on reusing it into different applications. So our idea of integrating algae with all these three kind of waste stream is to recycle the nutrients those are present in these waste stream, and in turn to produce the biomass, the algal biomass that usually contain very high amount of the products like the biochemical that can be converted into biofuel, the protein that can serve as a protein supplement in the human food diets as well as animal fooders, and the natural pigments that have high market value. So I'm starting with the work that we have done with the RO reject from the drinking water units. So we have selected two kind of scenario. Like I believe that everyone knows that particularly in India, in the urban sector, we see that RO unit is almost there in every or at least every second house that is being used to treat the water for generation of potable water. Similarly, there are lots of industries those use the RO plant for production of potable water as well as in the food industry use. So what happened to the feed water that is being taken from the water resources, including the groundwater? So once we are treating the waters through the RO system, for example, if we are treating 1 liter of water, so suppose we are getting the 1 liter of treated water, almost equal amount of the reject will be generated in the process. And unfortunately, this reject that is being generated, particularly from the residential area, is ultimately going to be into the environment through the sewer lines, etc. So this creates lots of issues in the water bodies where they are finally ending up. So what we are doing, we are integrating algae here so that the nutrients that are present in the RO reject, we have done some analysis of the RO reject collected from different locations in India, and we found that there is a sufficient amount of phosphorus as well as nitrogen. Those are two vital nutrients for the microalgae. So, and the TDS is also high in the RO reject. So our idea is to link the algae so that we can convert the RO reject particularly safer for the discharge or reuse, and to generate the biomass that can serve as a resource for valuable product, including bioenergy production. So to begin with, because we pioneered the work on the RO reject from the industrial, drinking water unit. So initially, when we analyzed the water samples, we found that there is some less amount of nitrogen is present in particular cases of the RO reject that has been collected from the domestic water plant. So we initially work on having the different composition, like we use the nutrient media, which is the VG11, common nutrient media used for the blue-green algae as well the algae for cultivation. And then we have taken different ratio of RO reject into the media so that we can evaluate whether the BG11 is supporting the growth or the RO reject is supporting the growth. And interestingly, in the case where we have supplemented 25% of RO reject in the VG11, we found that the growth of the microalgae was at par with that we observed in case of the BG11 alone. And interestingly, when we analyzed the biochemical composition, we found that the lipid accumulation, particularly in case where the 50% RO reject is being used, was just double to the control system where only the nutrient media was included. So this shows that the RO reject not only improving the biomass production, but at the same time, it is also changing the metabolism of the microalgae, resulting in higher accumulation of these compound, particularly the lipid, which has very high value in terms of the biodiesel production. So I won't cover much detail because of the limited time, but we have recently published this paper in the water research. If you are interested, you can follow that. Then we try to understand the energy potential of the RO grown microalgae and then theoretically calculated the stoichiometric methane potential and the theoretical methane potential. So SMP is based on the elemental composition of microalgae as well as TMP is based on the biochemical composition of algae. And surprisingly, we found that the microalgae that has been grown in the 100% RO shows the highest value of SMP. And in line with that, the TMP value was highest in case when we are using the 50% RO with the 50% VG11 media. Then just to see the applicability of the process with the different other algae. So we tested 4 more algae available in the laboratory here in IIT Roorkee. So one native strain has been isolated from the drain, which is to be identified. So we found that the highest biomass yield in case of Chlorella sorokinina was in the VG11 only. But when we compare the biomass productivity of other strain like Sandesmus obliquus, so the highest biomass productivity was in case of 50% RO reject. Similarly, the biomass productivity was also high when we used 50% RO reject growth media for the native strain. Then we also realized if we can recycle the treated water. So we found we evaluated the phycoremediation potential of microalgae and we found that the CS, which is the Chlorella sorokinina, was able to remove or reduce around 77% of the nitrate from the RO reject. At the same time, the up to 82% of phosphorus was removed by the Sandesmus species, and the TDS was removed in almost all the cases up to 95%. And as in case of Chlorella pyonotrosa, the biochemical composition was also improved for these food tested algae, and the highest lipid yield was reported with the Sandesmus species, and the protein accumulation was high in case of the native strain that we have isolated from drainage line, and the maximum carbohydrate productivity was with the Sandesmus obliquus. So this shows that according to the designated use of the microalgae, like if we are interested to produce more protein, we have to select the microalgae so that that can produce more protein when we are using the RO reject water. So again, this work will be very soon available online for your reference. So this is the story of RO reject that we have worked on. Then the hydroponic wastewater that we have been working. So the hydroponic, as I told you, that it's a kind of soil-led cultivation in which we are using the nutrient-rich solution for the crop cultivation. And after the crop is harvested, the effluent is being discharged because we cannot recycle it again for the next cycle of cultivation. So this effluent we analyzed, we collected it from nearby hydroponic farm, and we found that there is a sufficient amount of nutrients, particularly the nitrogen and phosphorus there in this effluent that is being generated from the hydroponic practice. So it shows that we can utilize this hydroponic effluent for microalgae cultivation, but unfortunately, when we chemically evaluated the composition, we found that the root exudes those are including the sugars, organic acids, and amino acids, somehow hinders the microalgal growth, particularly this benzoic acid, which is highly toxic to the microalgae. So we started our work to see this benzoic acid as a model compound, and we tested it at different concentration, ranging from the 0 to 80 mg per liter. And interestingly, we noticed that up to 40 mg per liter, the benzoic acid was not suppressing the growth, but it was improving the growth of the microalgae. So we see this stimulation in the growth. Similarly, with the chlorella sorochinina, up to 20 mg per liter of this benzoic acid, growth was promoting rather than being inhibited. So this conclude that if the hydroponic effluent contains low level of benzoic acid, so it will be very much useful in case of microalgae cultivation for resource recovery as well as recycling of the hydroponic effluent. Then the third scenario where we are working on the sewage treatment plant to integrate the microalgae in the sewage treatment. So for this, we initially tried to work on the flask scale, then when we scale up the process to the attached growth system where the microalgae were growing on the biofilm system. Then we devised this suspended culture having the attached device also, which is known as the hybrid PVR, and we have filed the Indian patent for this work particularly. And this system provides much more high biomass production compared to the other conventional system. So this biomass which is being produced using the wastewater is being utilized for the biofuel production, and the treated water is being tested for its recycling. So then we tested, like if we focus on the microalgae, one of the common application of the microalgae is to produce the lipid for the biodiesel production, and the glycerol is generated as a waste product from the biodiesel production process. So we utilize that glycerol to convert the phototropic microalgae growth into mixotropic, so that the waste that is being generated at the end of the point is being recycled back to the system, and microalgae can utilize that glycerol as an external carbon source. So we did this, and we found, and we optimized this glycerol concentration, and we found that the dose of around 3 mg per liter of 3 gram per liter of glycerol is growth promoting. And we found that in the attached growth system where we are supplementing the glycerol, so if we harvest the biomass at every 3 days, so we notice the highest biomass productivity in this case also. Along with this, the wastewater treatment, which is termed as FICO remediation in case of the microalgae, was also good. Up to 80 or 89, 85% of removal of the phosphate, COD, etc. were recorded during the work. So this shows that the water that is being utilized for the algae can be recycled back to the system, or it can be taken into the environment, can be disposed to the environment safely. And one thing which I could not make it possible to put in the slide is that if we are reculturing the algae in the same effluent, so we are able to produce the extracellular polysaccharides in very high concentration. So that work is also have been filed for the patent, and I could not share more detail about that particular work. And when we analyze the biochemical composition of the microalgae that has been grown under the phototropic mode as well as the mixotropic mode, we found that the glycerol supplementation is improving the composition of lipid in terms of the more monosaturated fatty acid, which is a good sign that the lipid which is being produced under mixotropic mode will be more suitable for the biodiesel production. So based on the work that has been carried out in this particular on the sewage treatment plant and the sewage wastewater treatment and resource recovery from the microalgae, so we have recently launched a startup which is E3 Clean Bio Private Limited. So that will be looking for the future work related to the scale of the process, etc. And we have received the grant from the DST to as a seed money to incubate that particular company in IIT Roorkee. And yeah, one more interesting thing, this is the last part of this slide, that the presentation. So whenever we deal with the wastewater, we should also give some more focus on the pathogens also. So either we are looking for the resource recovery, or we are looking for the safe discharge of the treated water, or the recycling of the treated water. So we should always focus on the pathogens, which are very common in the sewage particularly. So for the removal of pathogens, we again utilize the capabilities of algae, because algae are having the ability to produce some extracellular polysaccharides, which are usually remain on the surface of the algae. So this is the one fundamental which may help the capturing of the pathogens from the wastewater on the microalgal cell. Secondly, when the algae grows in the media or the water, they convert the pH into alkaline, which is not preferred by the pathogens in some cases. And third one, the light and dark phases may also have some advantage in terms of the deactivation of the pathogens. So we did some work with the model strain, which is the E. coli, and we found that the CP, Chlorella pyrenodosa, was able to remove around 90% of the E. coli within 3-4 days. And similarly, when we tested with the real sewage water, we noticed around 80 to 80% reduction in the total bacterial count. And based on these, we have identified that the photooxidation, competitive interaction, as well as attachment are the major possible mechanism for the entrapment and the removal of the pathogens from the wastewater. And based on the work, we are now working to develop biofilters that can be installed in the sewage treatment plant, again based on the microalgae metabolites as well as microalgal cells, and that can easily replace the conventional disinfection process, which are based on the chlorination or the UV based disinfection. So we are working on this, and we will be able to do it in next 1 or 2 years. That's all for the technical part. Now I want to introduce my team. So if you want to know more about our work, you can browse the links here. And now I'm introducing my team. The Mohit Rana, who is in the advanced stage of submission of his PhD thesis, work on the algae-based biofuel production along with the wastewater treatment. And he also conducted some experiment on the nanoparticle role in the microalgae metabolism. Then Ankita Bhatt, who is working on the pathogen removal from the wastewater using the algae. Then Mamta, who is particularly working on the RO reject water for the metabolite production and resource recovery. Then Pooja Upadhyay, who is working on the water bodies, particularly on the GSG emission, greenhouse gas emission from the water bodies, and the requirement of the techniques that can minimize the impact of the GSG emission from the water bodies. Akansha, another student who is working on the integrated system, where we are trying to integrate the constructed wetland, one of the most popular natural system for the wastewater treatment with the algae, particularly in the rural sector, because the rural sector do not have sufficient infrastructure for the wastewater treatment. So if we can develop some system, so that will be add on the value in terms of the sewage treatment. And Harshit, who is working on the hydroponic effluent resource recovery. So that's all from my side. And these are some of the funding agencies, including the Ministry of Education, who have funded our imprint project, Science and Engineering Research Board, Government of India, then Department of Science and Technology, Government of India, IIT Roorkee itself, and then National Mission of for Clean Ganga under the Ministry of Jal Shakti. They have funded the project on the constructed wetland. Then S2O Mantra is the industry partner in the imprint project and partially supporting the funding. And then finally, the Uttarakhand State Science and Technology Council. So thank you very much.
Excellent. Well, thank you for your excellent presentation. I think we've all learned a lot about the algal treatment of wastewater. Okay, the first question really was to you. I mean, you have explained some really very, very interesting results, and I can see huge interest for water treatment industry in what you are suggesting. But what sort of scale are you at the moment? Are you at laboratory or pilot scale, or is there already industrial interest?
Initially, we did some work, particularly in the hydroponic and RO scale. So the RO water work is at the scale of around 40 liter of reactors. And the sewage water, we have a scale up to 200 liters. So initially, like, we are still working on the laboratory scale only. But in future, we will be trying to integrate the process with the existing sewage treatment plant within the campus. We have the 3 MLD sewage treatment plant in IIT Roorkee campus. So as of now, we have the 200 liter maximum capacity that we are doing.
Very good. Thank you. It's great to hear.
Yeah, thank you.
Any other questions in the room before I pick on some? It's only a Friday afternoon joke. Don't worry. Don't look so nervous, honestly. Thank you so much for your presentation. I think it has been really eye-opening to all of us. And I think if we, when this is getting applied across India, you will be saving lives too with this type of treatment also. I do have a great pleasure to introduce my colleague, a research professor at Luke, Professor Erkki Verkasalo. And he is a professor in our organization in the wood science and technology area. He has worked in Mettler since 1998, which as you remember my presentation, you remember that Mettler went into become Luke, one part of Luke, and Luke since 2015. So I agree with you. We got the same right date for the start of our organization.
This time Brexit doesn't.
I was hoping not to mention that. And as an adjunct professor, Erkki has worked at the University of Eastern Finland since 1999. He has vast expertise in the areas of wood-based materials and products, especially for the construction sector. I think I will leave it there because there are also international affiliations as well in your background, but maybe you would like to introduce yourself too and your presentation, and I think we've got like 25-30 minutes.
I was actually nominated as a professor in 1998 at Mettler to help utilization of materials and develop products for small and medium scale industries. And that time it was the first professor of this kind. Otherwise there was not so really such kind of say stakeholder oriented or impact type approach at Mettler. But after that there have been other ones who are working in a little bit same way. But anyway, this has been my role, which has changed a lot during those years, and also the topics with which I have been working and our group has been working has changed quite a lot. So in this way, the idea is to show rather some issues that might be interesting for India and Finland together, both for scientists and both for practitioners, and this way, in the sense of this group, open more tracks to find something common in the future. And this is related to circular bioeconomy in one way or another. So firstly, as the background, we all know that globally changing strategic and operative environment carries implications to the needs of RTDI, and there are actually more expectations that we know and that the natural resources can carry. So we have to make choices, but the research and development activities can help in these kind of decisions. As regards the short-term interests and challenges, security of supply in the rapidly changing world is one issue, climate change mitigation is another issue, and the third one is reducing fossil energy and materials. Is a big issue too from the Finnish perspective, and I believe that is the same thing also all over the world right now. As you see, there are very many sub-targets here which should be somehow reached to make a final, bigger solution about and how to proceed in the future things. So here in this country we have the acute thing to balance between biodiversity, carbon sequestration and the use of forest resources, and looks like there are no simple solutions, but must say that the key messages from our perspective can be like boreal, temperate and also Mediterranean forests and forest dynamics are not similar. National forest inventories make the basis to offer framework and solutions for monitoring and strategic planning at the European level. And then the substitution effects of the use of wood are not fully recognized even in the new European Union Forest Strategy for 2030. I think that in other countries like India, you haven't been thinking the forestry role so deeply because its role is not so prominent at all as it is in our country. But anyway, some of the things might be similar which should be solved. So regional context is an important issue here, but also when we think about European context, and I believe also the Indian context, while India is such a big country, which has such a diversity between the regions, so competitive edges and solutions based on what are the opportunities and needs should be the basis here. In one European project where I was present, we tried to identify in European level how we see these things and what is unique or transferable from one region to other region as a kind of model. And here in Northern Baltic area, we recognized that industrial symbiosis and business model innovations where supportive governmental environment and good access to forest resources are in the background is one of them. We have quite good multi-actor cooperation between the different parties of the triple helix collaboration here, and we have quite well-functioning value chains. But there are things, especially in the technology, there are things also in the regulatory framework and the other parts of the problem area that should be solved. This graph shows what is the added value of bioeconomy as a whole in Finland in quite a normal year, 2019 in this case. I must say that during the last 2 years we have been living such unexpected conditions that those figures don't reflect the true opportunity and the true future expectations, but this is closest to the reality. It has been counted that the share is 208 billion euros of the whole size of the national economy here that you see. That 13% comes from bioeconomy, and the forest sector makes about 1/3 of that, quite much in our case. So one background factor is cascading, where the idea is to go in the whole concept of natural resources utilization in Finland, and that means efficient utilization of resources by using residues and recycled materials for material use to extend total biomass availability within a given system. So there have been different approaches here and how to go further. The practitioners and decision makers are not fully content with the implementation or rather introduction of the international cascading principles where only material use should be a big issue. We are living in a cold country with long winters, so we have to heat the country in one way or another, and so far wood-based materials plus peat and something else that comes from the nature have been present here, and it looks like it is inevitable in one way to use that resource still now, but in an advanced form from what we have experienced so far. So the cascading use of wood here means that we have to rank the different actions and what to do for that. So firstly, the less we increase consumption, that means the best for the cascading too. So if the materials are used less, we are in a better situation. How realistic is that is of course another question. So starting from circular design models, refusing, rethinking, and reducing. First, then going to optimal use models like reusing, repairing, refurbishing, and then go to value recovery models where we end up to remanufacturing, repurposing, and recycling. But the strategies and how to go further. Some cases how this could be applied. For example, wood waste from construction sector are an underutilized resource, and it is an underutilized option to increase climate mitigation and also cascading, principally increasing in our country. And here in the right subgraphs you see the situation in Germany and Finland, for example, and so little actually for the construction and demolition wood wastes are really used in a processed format and quite much is actually used in the clean form. And that indicates that there is much to do to improve the situation, to go further to usable products with longer life expectations for the materials bound to the products. Then another thing is what to do with plastic wastes. And a solution is replacing plastic film, for example, with wood-based film as a barrier in food and other packaging. But one has to remember that packaging is a tremendous user of plastics in the world, and also in our conditions it looks to be more than 44% of the all plastic consumption. So if we can replace that with something nature-born or develop it to more nature friendly form, so to increase its service life by reclassing, then we go to a good direction. Then I already indicated the importance of energy, and wood-based energy. It has been a success story at us as regards heating our towns and cities and generating at the same time electricity for national networks. Now these plants are coming to the end of their service life, and we have to find something else, either to replace them or to develop them further, and that is a big issue where we should do something else. Of course, we can develop the products that these plants develop to something else than what we have done so far, and there are a lot of options how to do it. Then wood construction has recognized one way in a circular bioeconomy to especially improve the food, so more handprint, but also footprint of using the natural resources in the industry sector. There are several reasons why timber construction otherwise should be promoted. That we have had a big percentage of wood in small house building, more than 80% so far, but not really in high-rise buildings, either being apartment houses, office buildings, or commercial buildings, or whatsoever. The percentage is still now less than 4% in that sector, despite quite massive efforts from the public sector and also industry conglomeration sector to improve this situation. So these examples come from the province North Karelia where I live, and must still regret that most of the concepts are still at the conceptual level and no repeatability of the building. The options haven't really been developed so far. But what we want to have is industrial wood construction. Make the building elements as ready as possible, already in the well-protected indoor conditions, and at the same time shorten the building time on construction sites. And in my view, this option looks quite good and can be adopted also to many other countries. Actually, the Finns are themselves adopting it from other countries, so it's not a Finnish invention at all. So what is needed here are more developed engineered wood products, which can be done either by manufacturing through laminating with adhesives together smaller wood sections or laminates or veneers or strands of timber, or material can be obtained from a diversity of wood-based materials, can be large wood, small wood, timber veneers, strands, flakes, chips, sawdust, planes, cut-off pieces, fibers. And that is why, while the material diversity is so large, this option could be applied also in very different conditions in the world. See, there are fibers, recycled wood, sometimes post-consumer wood, sometimes, and other biomass sometimes possible to use here. One Finnish success story are modified wood products, where the idea is to extend service life of wood in situ uses and improve long-term durability, structural safety, aesthetics, and even comfort. And there are several companies who are doing that business, and it's already export business nowadays. We can imagine that in a subtropical and tropical country like India, for example, long-term durability is an important issue. If wood is to be introduced more to the practical the building activity over there, but of course the hazards are different than here, and you have termites, you have different microorganisms causing deterioration, and you have a different climate with storms and etc. So we cannot really think that this system can be straight adopted from here to your condition. Then something that is related to the urbanization also here. It is one idea that wood construction and green infra development in the cities should support each other as regards the transfer to green economy. So there are several reasons why trees actually shelter both houses and people, but they also cause some risks especially for the durability of the houses, etc. So this is still an idea that is under research at us. Impact of climate change on the structural health of buildings is somehow related to the previous issue, and it is quite a multidisciplinary item where things like structural microclimate, building materials themselves, structural design, microbial load, building regulations and environmental policy development, and region and climate conditions are in the background. Another European project during the last years that has generated some ideas how to go further in building with wood is Basahaun, and it means sustainable wood construction in order to foster rural development and urban transformation. The idea is here to develop the incentives so that both city development and the rural development get the benefits from the success. And of course, the idea is that while most of the production occurs in the countryside and most of the building occurs in the cities, and they complement each other, but there must be benefits that go in both directions between them, so that the practitioners in the value chains really get interested in these things. And then we come really to the role of the different stakeholders and their motivations to be within this development. And I am sure that it is also valid in India, like in Finland, that the companies and other stakeholders, regulators, and other public decision makers both have to be involved if true success is aimed to achieve in this field. So, of course, in a country where we have more than 70% of land area forests, we think about using wood also in the future, and comprehensive use of wood biomass is one of the main targets of LUKE, actually, in the biocircular economy. And then we don't talk only about the physical form of wood-based materials and products, but we do go to the chemistry quite deeply, and that is the idea that in addition to wood construction or say spin-off type development of side stream achievements, also more competence is needed in the chemical governance of the wood properties, and going further from the, say, micromolecular level to nanotype materials is something that has already been started. Then remember also food and feed ingredients that can come also partly from sawdust, bark and forestry residues, and there have been quite many trials to start this business, but in my view they are mostly still at the stage of say, not really piloting, but a little bit closer to the commercialization than piloting, except the textile industries. So also novel biochemistry applications are available for wood industries, and actually my colleague Anush Kumar, who is present here, has been done quite a lot during the last years in this field. We have now platform for fully bio-based glue formulations for solid wood and composites, bio-based materials for 3D printing composites, even in electronic materials, bioester-based hydrophobic and antimicrobial coatings from suberin and cutin monomers of wood, and delignified wood materials and products for insulation and structural uses. Maybe I have a mistake here. Could it be actually liquefied wood? Anyway, so here are some ideas still about how the Finnish forest biotechnology systems can enter to market and what is needed. We need circular value-added streams towards zero waste processes and closed loops. We need carbon neutral or positive production incentives that minimize CO2. Nutrient recycling is one option. Water purification, soil remediation, geoconstruction, base materials for batteries and metallurgical processes, synthetic biology, health and well-being products. Then bio-based solutions can be, for example, nanocellulose and extractives-based biomedical solutions, biocomposites, biofuels, biochemicals, lignin-based binders, proteins. They can be sustainable textiles, cellulose fiber production, recycled textile ecosystem development, recycled textile fibers for different end users. They can be packaging in the first hand for bio-based barriers, thinking traceability and digital elements, and package also as a service option. Then plastics, as I mentioned, bioplastics, plastics, recycling and use of recycled plastics come here. So then about international collaboration and cross-border transfer, and we do have some principles to follow here, and to prioritize the actions. And of course, countries or regions which have about similar natural conditions and or strategic or operative environments that are the easiest one with whom to collaborate. Countries with positive attitude towards climate change, mitigations, carbon neutral society, substitution of fossil materials and energy, four-angle sustainability principles, and green transformation of economy share the values that we try to follow in our incentives. Countries with acceptable political and democracy framework and societal values are nowadays a thing that the politicians always think, and the countries and societies with whom collaboration can provide benefit for both parties, of course. And here we should consider industry development and trading potential, research and technology development and innovation, service trading, knowledge transfer and development, and long-term relationships development. Basically, the collaboration between developed countries in Finland has been so very much focused to Europe and North America, but I would say that Eastern and Southern Asia and Latin American selected countries should be more in the palette because of the transformation that we expect in the global economy in the future. Then we do have also the developing countries and CIS countries where the collaboration is more aid-based than with the previous group of collaboration countries. And then it involves different and miscellaneous goals and modes, of course. So this is the list that is my own opinion about which kind of things could form basis for the Finnish-Indian collaboration, just for suggestions. Firstly, added value and new products from forest and biomass together. And for example, wood-based textile fibers to replace cotton or synthetic non-renewable material-based fibers, substitution of plastics, etc. I don't know how challenging political discussion is it in India about the remaining cotton production, but there has been so much discussion about environmental concerns related to cotton production, especially to lead to scarcity in water resources is something that should be somehow considered. Then nature-based products and environments for well-being and medical care of people, which has been a big issue today in the discussion, is one of them. From the Finnish perspective and also in Luke as ongoing research, antimicrobial, antiviral and aesthetic wood together for health, well-being and better psychophysiological effects for living and working in buildings could be one option, not only to think about the sole medical purposes. Side streams and low-value raw materials for food and feed, biopesticides, biohybrid materials, recycling and reuse options for wood processing residues and post-consumer wastes, techno-economic suitability and availability of domestic tree species for building, and for biorefinery applications. This is something that I don't have an answer how this should be understood. But anyway, in India, you have some forest resources, but probably there are lands which are not so suitable for farming, which of course should be the priority in a global context of food production. But let's think about this too. Then wood in urban and rural environment, as I mentioned before, including engineered and modified wood products plus industrialization of wood construction can be included. Bio-based wood protection, product quality and long-term durability in your and our climatic conditions, and resistant buildings and structures against fire, storms, and biotic and climatic hazards in both climates is another thing. So, as you noticed, that these were mostly some kind of summary type opinions, not really results of any individual project, but I understood that the idea of this meeting was really to raise interest and discussions, not really to go to a scientific seminar level here. So there will be also included in this material a little bit same things that John already introduced, but also about what is our wood type research at Luke nowadays. Thank you for your attention, and hopefully you didn't feel this as unnecessary extending of the day, but rather consider this as a sugar at the bottom. Thank you.
Thank you very much, Erkki. Now we can open the floor to some questions.
So, Erkki, my question to you is that you have suggested few collaboration opportunities between India and Finland. Are there any ongoing collaboration projects going on at the moment between UK and India, of which you're aware?
I am not aware of Luke as a whole about what is the situation nowadays, but I would say that there has been some starting effort through Anush during the last year, but so far this is a very new thinking process to us, and how to approach India and how to find the common items. I don't know, but maybe John has better knowledge.
I can't say I'd ever have better knowledge than you, Erkki, but I would, on this particular topic, I think one of the key... We don't have, as far as I know, any ongoing projects at the moment from within Luke, but I of course, the willingness is there. But as we are a small organization in Finland, we need to really be able to focus and find where that niche is, where we are needed. We can't look at the whole of the continent. We need to really home in and potentially work with local players like the IIT, for example, that were online today. There are, of course, we think there's a lot of technology that we have that would be worthwhile looking at as something that could be transferred into India. And of course, I think that could be a discussion for another day as well. And I do agree that there is a lot of work that we are doing, for example, on the forest inventory side, smart forestry, which maybe some of the techniques, even if the forests are different, would maybe help to minimize the risk of forest fires. And whilst you were speaking, I took the liberty of looking at my phone to look at some of the statistics, and it's quite clear that I think it was something like 3 million reported forest fires in 2022 so far. Just over 3 million. And it's sort of around the 2.5 million the previous year. So it is not getting better, but it's moving by quite a big amount. That's one thing. But there are also other techniques which Erkki had already alluded to. For example, the antiviral, antibacterial technologies, or the way that you can treat from wood-based products to generate these types of materials. Now more than ever, the world is aware of the problem of viruses, and the expectation that we are not over it. We are going to get more. That's not a happy thought for a Friday afternoon, but basically the chances are there. So the idea that you could actually have some form of antiviral material that could be built in to masks, for example, would be really fantastic, I think.
So while thinking that India is anyway much more an agro country than a forest sector country, so we should think about those opportunities and, for example, how to replace the current fertilizers with some others that may come from natural sources or go for biopesticides. But I have no figures in my mind. But I can imagine that the consumption of those in India is so tremendous. But we also in Finland need them in the future, and actually already now in the current global trading the situation. So about the industry incentives, it is sure that the Finnish ways to introduce wood pulp and other wood-based materials to textile industries are something where these companies, Spinnova, Metsä Group, through their spin-offs, they are already discussing with the Indian buyers with the deliveries and probably also common development actions. I know that sawmill and plywood industries have tried to make some market studies and even a collaboration platform attempts in India. But while wood is so badly known actually as a building material and less used nowadays, how I have understood it, first that there should be some way to provide information about and what is the potential to use wood and what does it require in your climatic conditions to increase it and what it requires in your demographic development situation nowadays. And of course it's in vain to try to think it from the Finnish perspective, that we should go to see what are your needs there, and then you should of course think about this thing about that can you supply the material for building of wood with your own resources in the future. And Anusha and me have had discussions that why not to try to introduce species which are known to be durable for construction also in India in the future, more than until this.
So it was great to hear inspiring talks on biodesign, biofuels, and environmental management. I would like to thank all the speakers, and we came to an end of our event today. And I once again thank all of you for your great engagement throughout the day. And now I am glad to introduce Dr. Anuj Kumar, Senior Scientist at Natural Resources Institute of Finland, Luke, to give closing remarks. Dr. Kumar, the floor is yours.
Good afternoon, everyone. I hope all of you are still active to listen 5 more minutes. On the behalf of FINERAC committee, I'm happy to announce that we had more than 100 participation online and we had around 45 in-person participation. These includes students, research scholars, professors from universities and research institutes, including industries also from different parts of world. And our special acknowledgement goes to our dignitaries who graced our event today. Special address given by Dr. Johanna Kallio, Director, UPM Biomaterials. Our keynote speakers, Dr. Rajesh Gokhale, Secretary, Department of Biotechnology, Government of India. Research Professor Maria Pentila from VTT, Technical Research Center. And Mr. Ravish Kumar, Ambassador of India to Finland. We had 9 distinguished speakers from Finland and India and 3 respected session chairs. This year's theme was biotechnology, and it was divided into three technical sessions. First session was on biomedical technology, second was on synthetic biology, and third and last one was on circular bioeconomy. So I would like to express our sincere thanks for showing the recent biotechnological development in Finland and India, and as well as it is so fascinating to listen from human cells to the now we are closing with the wood science and technology, and that was the main motive of to bring people from different background, and so they can showcase their expertise and bring up this FINERAC community more stronger. In the end, but not least, our sincere appreciation to our co-host, Embassy of India, Finland. Thank you so much for all the support and organizing this really nice event. I hope we will build more stronger FINERAC community by connecting more researchers and academicians from India as well as Finnish researchers. FINERAC could be the leading platform for joint scientific cooperation between India and Finland in coming time. And thank you again, all the participation.
Now I am glad to introduce Ms. Mridul Sharma, Marketing Executive, Embassy of India to Finland, to give vote of thanks, who has been working relentlessly for the last couple of weeks to make this event so lively and nice. So, Ms. Sharma, floor is yours.
Thanks to you, Vidya. It's because of you, Anuj, Sarang, and Vinay. All together, the whole team of Working Group 2 who made this event, a success. I would like to take this opportunity to, give you a status update of our relationship with Finland. Now, overall, the trajectory of our relationship, has been quite positive, and it is optimistic. If you are aware that, both the prime ministers, they met in Copenhagen earlier this year, and then later on, Minister of Economy Mika Lintilä, he was on a visit to India in April, and there were a few cooperations that we had agreed on, covering the areas of quantum computing, ICT, startups, sustainability, and circular economy. Finland has announced opening of a new consulate in Mumbai. And as you all know that, Finnair has started to fly to Mumbai. There is another city that Finnair will soon be starting its operation. I will not, disclose that city, but it's coming soon. Also, we have a strong presence at Slush 2022 this year. So we are asking 30 Indian startups to participate at Slush. And the sectors that we have identified, are for digital partnerships, which includes AI and So it includes AI and quantum computing, and mostly it's related to IT fields. Of course, sustainability, including renewable energy, smart energy, and educations and health sectors are also our focus sectors. We are, of course, looking to collaborate with the Finnish companies to do business with India and also vice versa. We have also recognized that there is a need of an institutional framework for a more meaningful interaction. So for that, as an embassy, we are reaching out to different cities outside of Helsinki to establish our relationship with cities in Kuopio, Jyväskylä, Tampere. Ambassador has visited Tampere, Turku Pori and Kuopio in previous in couple of years, but this year we are planning to take a city visit to Vasa. So if you have any, especially for Indian diaspora, if you have any contacts for Vasa, you think who will be able to help us map out companies that are important for us to interact with, please do share their contacts with us. We would like to, do our interactions with city under the series called India Means Business. We have done India Means Business in medical health tech in Tampere last year in October. And the whole focus was to take India outside of Helsinki and projecting India as, a strong destination for investment. We are also looking to work together with Indian entrepreneurs and professionals, for this outreach. So please feel free to write to me or to my colleague Anni, with your suggestions of companies and clusters, whom we should interact with, when we are going to Vasa. I would just, mention few initiatives other than India Means Business in my closing remarks. We have an organization, or you can say forum. It's called India Business and Professionals Forum. I don't know if many of you have heard about it, but it is one of the organization that is bringing Indian professionals and entrepreneurs on a common platform. So if you have not joined that forum, please do so. The link is already available on our website, so you can register yourself, and we have a lot of upcoming programs and interactions with Finnish dignitaries in the month of September. You can find more details about it on our website. Of course, then one of the focus, I would say, forum is FINERAC. And FINERAC will give us a platform for scientific research and common practice that can actually carry forward our relationship in the area of exploring best practices in scientific research. And Friends of India is another cultural organization that we have that is run by embassies. So it brings all the Indian community together. Open House is one opportunity to meet people from diverse background. If you want to meet the ambassador or you want to have a one-on-one talk with him, you can free to join Open House. We always list the date and we announce the date on our websites. So if you want to be a part of the Open House and you want to come and meet the ambassador one-on-one, you can always write to his office and they can provide you more details on it. But, before I let you all go, I'll be failing in my duty if I don't thank everyone who has helped me putting this event together. Vidya, Sarang, Anuj, and Rupesh, and my teammate Anni with me. She's there in the back. But huge support from these people, and also a very big thank to panelists who have traveled from Tampere and Uvascula to participate in the event. Thank you very much for your contribution and time, and for putting up with my email spamming to ensure that you all get here to attend this event. And I would also acknowledge the contribution of FINERAC members for holding regular meetings. Here we are together, accomplishing FINERAC third year, in series. And let's hope so that, the fourth FINERAC day would also be a success like this one. Huge round of applause to all of them.